Welcome to my talk about steel decks with outward stiffeners. I am Palisson. I am a consultant engineer and I offer consultancy services to develop steel cold form sections and structures as well as composite slabs in accordance with the Eurocodes. I'm presenting here the calculation method developed within the GRISP project for steel decks with outward stiffeners. After a brief introduction to the topic, I am going to present the state of the art before the GRISP project in order to help you understand why the present methodology was developed. I am also going to describe the huge test program which was performed in order to provide the required data as well as provide the results of the testing analysis. Then I am going to explain the methodology to calculate the effective section and the moment resistance of a steel deck with outward stiffeners. This methodology was proposed as an amendment on Eurocode 313. Lastly, I am going to introduce the Excel file which was implemented to calculate span moment resistance for a steel deck with outward stiffeners. Let me introduce the topic of the talk. On this picture, we can see a composite slab with concrete and with a steel deck with outward stiffeners. Some composite slabs are frequently used in steel-framed constructions, in residential, commercial and industrial construction, as well for new constructions as for refurbishments. In order to increase the shear connection between the steel and the concrete, the steel deck contains outward stiffness in the upper flange, as you can see on this picture. At the composite stage, where the concrete and steel collaborate, the sheeting with outward stiffeners is in the scope of the standard Eurocode 411 for composite structures. But at the construction stage, where the steel sheeting is used as shuttering and has to support fresh concrete weight and construction loads, no existing study allows to calculate the moment resistance of steel decks with outward stiffeners. The Eurocode 313, which deals with the steel sheeting design, stipulates that first the effective section must be determined and then the moment resistance must be defined with the effective section. It assumes that the flange stiffeners are oriented inwardly of the section. It means downwards in the case of the upper flange, as we can see on the pictures. But the Eurocode 313 does not deal with the steel decks with outward stiffeners. Therefore, the only way to design them is to perform testing according to the Eurocode, but these testing are time-consuming and expensive. Thus, at the beginning of the GRISP project, we could observe that despite the frequent use of steel deck with outward stiffeners, there was no information given by the Eurocode or by literature on how to take into account outward stiffeners when designing a steel deck. So we could confirm that there was a real lack of data and relevant knowledge on how to determine the resistance of steel decks with outward stiffeners, and that an innovative methodology was necessary. The state of the art has allowed us to determine the GRISP project objectives and the methodology to be applied to achieve them. The main goals were to determine the missing technical data and, of course, a calculation method for steel decks with outward stiffness. The methodology consisted in a huge testing program in developing and validating a calculation method from these test results. This method was proposed as an amendment on the Eurocode 313. Now let's discover the extensive testing program which was performed within the GRISP project. The aim was to determine the resistance moment and, of course, a calculation method for steel decks with outward stiffeners. Here we can see the pictures taken during the testing. On the left, we have the test setup, and on the right, the steel deck after loading. The failure mode observed was a local buckling of the upper flange, and the moment resistance could be determined. The next step in our scientific process was to come up with a methodology to calculate the span moment resistance. The calculation of the effective modulus WF was based on an effective section with a stress sigma 1 in the upper flange and the same stress in the outward stiffener and a stress sigma 2 in the lower flange. Depending on the position of the neutral axis, the yield stress is reached on the upper flange or in the lower flange. Eventually, the moment resistance calculated as defined previously was compared to the moment resistance determined by testing. This comparison confirmed that the definition of the resistance moment, as shown on the previous slide, gives results that are safe and coherent with the testing results. These results allowed us to submit a proposal of amendment on Eurocode 313, consisting in addition of a new clause. This amendment stipulates that for intermediate stiffeners facing outwards of sheeting flanges, the calculations should be performed by taking the stress in the stiffener as equal to the stress in the flange. For the final part of this presentation, I would like to introduce the Excel file which is implemented to calculate the span moment resistance for steel decks with outward stiffeners. This Excel file was developed to provide a reliable design procedure and to encourage and facilitate the use of the steel decks with outward stiffeners. This file was validated by comparing its results with those of the tests. Moreover, this calculation method was made available to a number of industry users to check their relevance with the purpose. Thanks to this tool, you will be able to calculate the span moment resistance for a steel deck with outward stiffeners. To conclude, it is important to underline the following points. This design by calculation method was supported, checked and validated by a huge testing program performed within the GRISP project. Secondly, an Excel file was implemented to calculate a span moment resistance for steel decks with outward stiffeners. Lastly, this methodology was proposed for amendment on Eurocode 313. I hope I contributed to making you more familiar with this methodology. I invite you to follow my other talks about steel decks with embossments, hole profiles, and perforated profiles. I thank you for your attention.